Hello again. Let's get started. D by dx of x times the square root of x. That's d by dx of x to the 3 halves power. Remember, by the laws of exponents, this is x to the 1 right here. This is the x to the half right here. And by the laws of exponents, you add the 1 here to the 1 half and you get 3 halves, which is here. So we do d by dx of x to the 3 halves. Now guys, we execute the derivative, which means we bring the 3 halves down, and we subtract 1 off the original 3 halves up here and get 1 half. So we have 3 halves coefficient times x to the power of 1 half. Of course, 1 half is my exponent, and 3 halves is my coefficient. Now, a lot of times your professor, he or she, will want this in radical form, so we write this is 3 halves times the square root of x, like that, okay? So there's that one. And in a similar fashion, d by dx of x squared times square root of x. Now that's going to be d by dx of x to the 5 halves. Again, what you do is you add 2 plus 1 half, and you get 5 halves, which goes here. That's by the law of exponents, because the square root is understood of x. The square root of x is understood to be x to the 1 half power. Okay, and 2 is understood to be 4 halves. 4 halves plus 1 half is 5 halves. Now we're adding the exponents. We're multiplying these overall terms. Yes, this is, at the end of the day, this right here is a times sign. It must be, okay, a times sign. But we add the exponents by the law of exponents. So we get this 5 halves here. Now then we execute the derivative. The 5 halves comes down. We subtract 1 off 5 halves. 5 halves minus 1 is 3 halves. After all, 1 is 2 halves, and 5 halves minus 2 halves is 3 halves. So there's that. And then writing that back in radical form, remember from this problem up here that we just did, x to the 3 halves power, that's x times the square root of x. What you do is you chunk x to the 3 halves off. It's x to the 1 times x to the half. X to the 1 is just the x itself. The x to the half is the square root of x. Okay, now d by dx of, in a similar fashion, d by dx of x cubed radical x. By radical, I'm meaning the square root in this case. Again, this is the half power. Now 3 plus a half, yeah, that's 3.5, but we want improper fraction, that's 7 halves. So we do d by dx of x to the 7 halves. But then we execute the derivative. The 7 halves comes down. We subtract 1 off 7 halves, and that's going to cut you down to 5 halves. And then in radical form, going back to what we did up here, we turn x to the 5 halves into x squared times the square root of x. Now, guys, that 2, really this is correct. And on pencil and paper, you'd want to create a little more space between the x squared here and the radical x here. So in order to avoid confusion, I'm going to insert what's technically superfluous, but makes this easier to read. I'm going to insert a times sign, because this 2 belongs with this x. It doesn't belong with the radical here. Well, really, there's an index of 2 up here in this case, but let's not play that game. This 2 strictly belongs here. Like if this would have been an x cubed, it would be a disaster to put this thing on the radical. And besides, even if you did put this 2 on this radical here, where would there'd be need to be another 2 that would go right here where this 2 is now. So let's not go there. Let's just leave it like this. And in a similar fashion, you can do this guy here. You derivate x to the 9 halves, and you'll fall down to 9 halves x to the 7 halves, and that's 9 halves x cubed times radical x. And for the same reason, I'm going to put that times sign there just for clarity of notation. And now this was totally redundant, wasn't it? Sorry about that, but oh well. That was redundant. I'll just get rid of this guy, I guess. No harm done, I suppose, but I'll delete him. So I'll delete that line there. Well, it's not that big of a deal. But anyway, let's look at this right here. D by dx of x to the n times radical x. Radical, again, being square root. That's going to be d by dx of x to the power of 2n plus 1 over 2. Now, I owe you a little bit of explanation. You're like, what in the world? This is x to the n, and this is x to the half. So that's really n plus 1 half. But when you get common denominator and you consolidate, you'll do n by itself plus 1/2 by itself. But when you get a common denominator, you get 2n plus 1 over 2, because n plus a half, that, let me, if that just bothers you, what's going on here, some of you, your intuition already kind of tells you what's going on, and you probably get it anyway. But what's going on is we're doing x to the n times, well, x to the half. That's trivial that we're doing this. I kind of did skip some steps there. Now, it's a legitimate skip. I mean, your professor will probably assume this of you, but I don't want to be the bad guy here. You invested your time with me, and I want you to understand the stuff. So the trick is to, by the law of exponents, that's x to the power of, n plus a half. I'll get this cleaned up here in a minute. Yikes. Come on, be nice. And then like that. Okay, maybe to be nice. So it's d by dx of, now that, remember, we need common denominator, so it's x to the power of, and then that n can be thought of in terms of 2. N itself is 2n over 2. Because that gives, and then plus, and then that, I'm going to leave 1/2 as it was. Okay, and then we get down there and do that. I've still not executed the derivative yet. Notice I keep delaying the execution of this derivative because I want to get this in the nicest possible form. And then that equals, it's, okay, a little misbehavior on the part of my program there. But then d by dx of, well, we just bring, hey, now that we got a common denominator here and a common denominator here, we can bring this and this together. And we get, well, 2n plus 1 over the common 2. The numerator, we get the 2n plus 1 over the common 2. And then come down, and then bracket, and then, yep. And finally, so there's that. But then, this becomes redundant because this is the same thing I've listed twice, so we won't do that. Let me get rid of that, the redundancy there. But I wanted to show off every step. So that's how the 2n plus 1 over 2 came to be. And then you do the derivative. Again, the 2n plus 1 over 2 comes down, and then you get x to the, what I claim is 2n minus 1 over 2. Well, indeed, I do subtract 1 off this guy, and I get this guy. If you find that less than obvious, here's the steps that I skipped again. So when you execute the derivative, now trivially this comes down. Hopefully we're getting used to that by now. The old exponent comes down, and then we do our x, and it's true. It's x raised to the power of the old guy minus 1. So let me just go ahead and come up in the exponent there. So, well, we had what we do up here now is we do the old guy that we had minus 1. So then put the minus 1 there. So we execute the derivative. This old guy comes down, and then x raised to the power of the old guy subtract 1. And then, so that equals, and then, well, let's see. Now, guys, what I do next, sorry for the pause there, but we need common denominator. You see this 1 here? It needs to be 2 over 2. So let's accomplish that, or let's do that. So I'm going to leave this guy alone for now. So that's just the same old 2n plus 1 over 2. So yeah, it takes it a minute. And then minus 1, but I want to write 1 as 2 halves. You can appreciate why professors skip steps. This does get torturesome, but I know, you're a newbie, and I respect that, and I want you to learn this. Okay, now let me do a little copy and paste for the sake of my sanity. Let me copy that and paste that right here. And what I'm going to do, guys, I just copied this and pasted it directly right here. Now, we have a common denominator too. So a over 2 minus b over 2 is a minus b up top, the whole thing over 2. So what I can do is just bring that minus 2 upstairs. Okay, and then, so what I'm going to do, and here's what I mean. I put the minus 2 right there. Because, like, this minus this over 2 is just this minus, like, a over 2 minus b over 2 is just a minus b all over 2. So there's that. That's just by the law of fractions. That's good old arithmetic. But then then what's going to happen is this plus 1 is going to bump into this minus 2 and give us a negative 1, aka it's going to give us a minus 1. So we got. Let's just see if we can go another round. Well, let's just clean this up. We're just going to clean up that numerator is all we're going to do. That's what this amounts to. So we're going to clean up this numerator right here. That is, when I say numerator, I mean this one right here, just this numerator. So let me paste. We've already executed the derivative. We're just having to clean house. We're just doing arithmetic and algebraic house cleaning. So 1 minus 2 is neg 1, so that's just 2n minus 1. The minus 1 is the negative 1. Whew. And then this becomes redundant, of course. Now, you know, I can erase this guy because that's just the same thing said twice. Okay. I'll save this. So there's that. And then now, so finally we got that. And you know what? Did I make a? I think I may have made a little bit of a mistake. I did. This should be a minus sign. Right, there's a mistake, guys, on my next step. This right here should be a minus sign. And I apologize about that too. That was quite clumsy. So let me make that a minus sign right there. This over here is correct, but I forgot why I did it. This is technically correct, but let me see why what would possess me to do it. That doesn't necessarily mean it's efficient, you know, just because it's technically correct. Indeed, you can write negative half as negative 1 plus half. Why did I do that? Okay, I see why I did that. For a good reason. It just saves me from having to rationalize later. But don't worry about all that. Here's what I do, guys. You see this n minus half? I turn it into n minus 1 plus a half. Because negative 1 plus a half is neg half. But I actually, instead of combining, I uncombine. And now what this does is I can, by the law of exponents, this x to the power of n minus 1 plus a half, that's x to the n minus 1 times x to the positive half. Because this, I just do this x to the n minus 1 times x to this positive half here and here by the law of exponents of algebra. And then, okay, and don't forget your original 2n plus 1 over 2. So I have 2n plus 1 over 2 times x to the n minus 1 times x to the half. And then just go into radical form, which your professor might want you to do. You have 2n plus 1 over 2 times the same x to the n minus 1 times the square root of x, because by definition, x to the 1/2 power is the square root of x. So there's that, and that's all for that one. And you're like, well, Jason, what if I don't, you know, you're like, well, no, you may ask, well, how did I get from here to here? I just fragment back off. I break the fraction back up. And then if you can break this up just like you brought it together. So if I want to break this guy up, that's 2n over 2 minus 1 over 2, but 2n over 2 is just n itself. I took this fraction that was together and I broke it back up. And this 2n over 2, I just reduced it back down to n. That's how I got from this exponent right here to this exponent right here. Okay? So I just broke this back up as x to the 2n over 2 by itself minus 1 over 2 by itself. But the 2n over 2, which is this guy right here, is just n when you can kill the 2's. Now 1/2 you cannot kill this 2 down here because 1 and 2, there's no kill off. But with 2n over 2, that's just n. Okay. I broke that. You can only do, and even then, you can only do that when you break this fraction up. Don't do it right here. You need to break the fraction up. And if that just bothers you, if you just feel uncomfortable about that, I'll copy and paste, and then and what I'll do is I'll go up here and I'll show off what I'm doing. I'm breaking this up. That's 2n over 2 and minus 1 over 2. Okay. But notice, guys, see that 2n over 2? These 2's cancel. This 2 right here and this 2 right here cancel each other, just leaving you with this n right here. So this 2 and this 2 canceled, leaving you with just n. Okay. And then I turned negative half into negative 1 plus a half, and that let me do this law of exponents step right here. Okay. I know that was a little hard, but this is going to get a little harder. It's just kind of the nature of the beast. There may be a homework problem. I don't want to do another problem for this video. You do this one, and you just need to go up here and use these steps up here. Of course, you got a much bigger number, 50, but the idea is the same. This won't take you long. Just do it the way I did these up here. You can use this abstract here. It's true that you can use this to do this, but you may find it more concrete and helpful just to use this. You would replace 4 with 50, and then so you'd have 50 plus a half is what? That's 50 and 1/2. Now 50 and 1/2 in proper mode instead of 9/2, 50 and 1/2 would be 101 over 2. 101 over 2, which is 101 up top and 2 on the bottom. Notice that 8/2 plus 1/2 was 9/2, and 100/2 plus 1/2 is 101/2. Okay, I'm talking about this when you do this problem right here. Okay, so that'll be all for this video. I'll see you on the next video. Bye.